All right, so in the previous video, we talked about what linear equations were all about. And that word linear, even though we may have the association of a line, a graph of a line, that only happens when you have a linear equation in two variables, like y equals mx plus b. But when you have a linear equation in just one variable, it's not a line, it's just a single point. I recognize it by the fact that it has a highest power of 1 on any variable, and I should get one solution. And the way that I get it is I isolate the variable. I isolate it. I put it on this nice, beautiful, and peaceful desert island. Okay, so before we actually do some solving equations, let's take a look at what we have here. We've got 7x squared plus 5x plus 1. Now, this thing is not an equation. Why isn't it an equation? What's missing from it? What's missing is an equal sign. So it's like you just got one side of an equation. Is it linear? Well, if you take a look at this middle term here, we got 5 times x. That's a linear term, but in the same expression, you also have 7x squared. It's to the second power. So this is technically what's called a quadratic expression. All right, and there's really nothing to do here except for simplifying or gathering, combining like terms. Are there any like terms here? What's it take to be like terms? To be like terms, you have to have the same variable raised to the same power. Now, we do have variable here, a variable, only one variable, it's x. It's the same number, it represents the same number. It's just that this one's being squared. Maybe it's the number 4, maybe it's 2, -1, who knows what it is, right? It's just a placeholder for something we don't know yet. And there's no variable that's raised to the same power, two different ones for us to combine up. This is in simplest form. The only thing that you could possibly do with this is, I don't know, maybe it's factorable. Don't know yet. That will be another video. But what we're doing right now is let's recap some vocabulary associated with this. Like the number 7 and the number 5 that's on there, those things are called coefficients. The number that's in front of a variable is called a coefficient. The operation is implied to be multiplying. Like that means 5 times the value of x. This means 7 times the value of x squared, and so on. Okay, the x, of course, it's the variable. We already talked about that guy. And then finally, the number 1 doesn't change. It's not variable like x. It doesn't change. It's always the same number. We call that a constant. It's a constant term. So one last thing, like terms have the same power raised to, or I should say, same variable raised to the same power. How do I combine like terms? What do I do? The way that I combine like terms is I keep the variable the same. I just add or subtract the coefficients. I just deal with the numbers that are right up front. All right, there's nothing to do on this particular slide, so let me come back over here, maybe add an extra page down here, and we can give it a try. We have 7x squared plus 5x plus 1, and there's no like terms to combine here, so let's just add some things in here, or maybe subtract. So maybe minus 2x squared minus, I don't know, 10x plus 3. Okay, so now whenever I combine like terms, maybe one of the things that your teacher did for you last year is like you underline it so you have this visual representation of what's like and what's not like. So I'm just going to combine up the coefficients and keep the x squared the same. I've got 7 of them. I subtract away 2 of them, and I've got 5x squared. Now notice that there's no equal sign over here. There's no other side, so it's not like I'm going to take this. I do not take this and go plus 2x to this side because there is no other side, right? I don't do that. Let me back that thing up. This is wrong. Okay, yeah, there we go. So I just combined those two. They're good to go, all right? And then how about some orange here? All right, so I've got 5x's. I've got -10 of them. When I combine those up, 5 minus 10 gives me a -5, keeping the sign of the larger one. And then lastly, green, that sounds good. A +1, +3, I have a +4. And that's it. There's nothing else to do for that particular expression. All right, let's come back over here. Let's take a look at this gentleman deadlifting about, I don't even know. Let's see, we've got 1, 2, 3, 4, 5, 6, 7. 7 times 14. If you know anything about Olympic weights, those are 45 pounds each. The bar itself is also 45 pounds. Look at it kind of bending right there. So that's 15 times 45, which is exactly a whole bunch of weight. Anyway, so I'm using this as an analogy. Let's say that we have ourselves an equation, and it works the same way with a barbell, and you want to keep that thing balanced. You don't want more weight on one side than you do on the other side. If you add weight to one side, you want to add the same amount of weight to the other side, right? That's what we do whenever we solve an equation. We want to keep it balanced. So here's our very, very simple equation. X is equal to 2. Now, really, there's nothing to do with that. But what I can do to it to transform it into a form that's still a true statement is maybe I add 1 to both sides. So in the weightlifting analogy, that just means I'm adding 1 pound to each side of that barbell. Not really going to happen. I think the smallest you can get is like 2.5, but we're just going to go with it. If I add 1 pound to one side, I'm going to add 1 pound to the other side. Or, you know, what I could do is I can subtract the same number of pounds from both sides. If I subtract 3 from one side, I'm going to subtract 3 from the other side. What else could I do? I can also multiply both sides by the same number. 4 times one side, 4 times the other side. And it's like making the weight 4 times as big on either side. And what about dividing? I can also divide both sides by some number, like on this example. I make it 5 times smaller on both sides for the weight. And what is allowing me to do all of those things are some properties of equality we basically are doing. The addition property of equality allows me to add the same number to both sides, subtraction property of equality, and so on. When I go to solve equations, I'm always doing the opposite of what I see there. So let's take a look. That's called inverse operations. And if you take a look at the pictures that are right there, we've got a pair of scissors, we got some tape, and we've got an eraser. And each one of them has some keyboard shortcuts on it. Control X means cut, Control V means paste, and Control Z means undo. Which of those three is closely related to this word up here, inverse? All right, well, if it was Control X, which is cut, that means I get rid of something. That's not what inverses are doing, no. Control V, that means I've taped or pasted something on there. No, that's not what's happening. Control Z, I'm undoing what I just did. And that's exactly what's happening with inverse operations. By inverse operations, we mean if I do addition, like I see in this table, what would undo that addition? What's the inverse of that? It is, of course, subtraction. What's the inverse of multiplication? Inverse multiplication, we've got division. Squaring, I've got something raised to the second power. Maybe I'm using the Pythagorean theorem and I've got c squared is equal to some number. If I wanted to undo that, I take the square root, right? And you did probably in last year's math class quite a bit of all of those things. Maybe not so much of this cubing. If you have an x cubed and you want to undo cubing, you take the cube root. It's very similar to the squaring and the square root thing. The last one, though, I don't think that you have any experience with. Exponentiation is when your exponent is a variable. So usually we're used to seeing something like x squared, but if you switch where the x and the 2 are, you get yourself an exponential. It's 2 to the x. And we want to be able to undo that kind of operation, and the way that you do that is with something called a logarithm. That last row there, definitely be something in Algebra 2. Not going to see any of it this year, just kind of a sneak preview. All right, so in the next video, we'll actually set about solving some linear equations.